Hiya guys, and welcome back to Aid's Workshop. So yeah, I've been AWOL for a couple of weeks. Truth of the matter is I haven't been in the shed much, so not much to report. Busy with work and all that. Anyway, that's another story. So sporting the Christmas jumper today, complete with reindeer, as it's that time of year again, or pushing on that way. I think I got another week and a half in work, something like that. Anyway, one of my subscribers sent a little job for me to do, so let's crack straight on with that. So this little viewer project, quick change tool post. It's going on a Warco WM180. One of my viewers has sent it across to me to help him out of a spot. It hasn't got the register underneath that will fit the compound on the Warco lathe. So yeah, it actually looks a really nice little tool post, this. Obviously I'm going to play with it a bit. Tools drop in. I haven't got the key for it, but an 8mm spanner does it. And locks off the tools. Yeah, I think there's 3 tools in the box here. Looks perfect for the Warco WM180, and it's well, this one's from RDG Tools. Let me just grab a rule. 2 secs, guys. So it measures well, 58 mil square. And the overall thickness is about 38. So yeah, I mean it's a good size for the 180. It's got the, let's have a look at the bore size. Yeah, it's got about a 10.5mm hole, so that's clearance on a 10mm bolt, which is great again for the Warco. But it will need the recess underneath to take the boss on the Warco lathe. So I think first thing I'll do is, oops. These should just, with a bit of jiggling and wriggling, come on, yep, out they come. So offset cam, that's how it works, and it pulls on the clamp here, which has got a spring in it, pulls it in, which pulls in turn, pulls the tool into the tool. So again, a bit of wriggling and jiggling. It should. There we go. So we've got it all apart. Now I can see on here a few little marks from a 4-jaw chuck. What looks like they're there, and there. I think the chap has had a try at it himself. Maybe failed on it, I don't know, or maybe lost the courage to do it. But yeah, I'm going to sort this out and put a rebate in the underside. So I've just pulled my my tool post out of storage, and as you can see, there's a boss on the bottom of here. It's 18mm diameter and it's 6mm thick. And as you can see, if I put the tool in, obviously it won't sit down on the tool post, so it needs a rebate in the underside. So we shall carry on and machine out a counterbore in here, 18mm diameter, just over 6mm deep, 6 1/4, something like that, maybe 6.4mm deep, clearance on this step, and happy days, we shall have a tool post that then fits the Warco. So my apologies guys, I lost a bit of footage. Yeah, quick change tool post. I've stripped it all down. I put, clocked it up, or clocked the existing bore up in a 4-jaw chuck. I got a bit of aluminium between the jaws and the block, but clocked it up, you know, to within as close as I could possibly get it. It was running about 100ths or so, a couple of hundredths out. I don't think the hole was quite round. Anyway, turns out I started to turn it, and the material's hard. It's not glass hard, but yeah, it's definitely a job for carbide. I'd guess it's, you know, I don't know, it's not 60 Rockwell, otherwise I'd be really struggling on a little lathe. But yeah, I reckon it's probably, you know, it's up there. It's good, tough stuff. So, on my existing tool posts, everything I've got on my machine, the step height, the depth, I should say, is 6mm. Well, that's the step on the compound. I'm going to go 6.2, something like that deep, because that does need to be a clearance. You don't want it bottoming out on the boss. The important part is the register. Now the register on the Warco machine measures up at 18mm or fractionally under, so I'm heading for 18.05, something like that. So first thing I do, as you can see, I've already had a little scratch. I come to somewhere around here, and I'll touch on the face and set my DRO to 0. And that'll give me a depth. And I'm basically going to peck away at this until I get an under diameter size, but I'm going to get down to my 6mm depth, and I'm going to finish off, you know, with this 0.2 cut at the end. So I've got a diameter of 16 there. I'm into 4.5 deep. I'm just going to come back off that face, just go in and peck it out. Yeah, smaller amount of that bottom face. Now I realise you can't see anything in here. I'll see if I can get you a better spot. In fact, not only can you not see in there, I can't see in there either. So I've got you a bit better view. I've just pushed you further back towards the lathe. Right, I think this material is actually case hardened, because once I've taken the skin off, as it were, it's softer underneath, but I've still got to go to depth, which leaves a little bit in that bore which is still hard. So I'm at 6mm, and I've got to there we go, that's depth 6.3. So I'm just going to take a series of pecks coming out, at that depth, and I'm winding out as I go, just basically doing the floor of the bore to depth. And I'm going to get to my dimension where I am now, which should be there. Just the very start of the cut is hard, as you heard it squeal there. And then we go into a bit of softer material as I pass the hardened bit, which I believe is surface hardened or case hardened. Okay, so we're to depth now. Yeah, I'm just over 6.3, and I've gone across that bottom face, so we need to take it to a diameter now. So I'll just see where we are. Just 16.52. So I know I can take 0.5 mm aside, so I'll just have a touch off on that bore, which is come on, just there. Set a 0 on my DRO. Let me take 0.25 aside, so that'll take 0.5 out of it. So that should be 17mm. Into my depth. Going to take the other 0.25, so that will have increased the bore by 1mm. Just work it back out the hole. Okay, I'm getting a bit of chatter in there. Okay, so let's see what size that is. I'm expecting just over 17.5. 17.58. So I'm going to take 0.1 aside. There's 0 there. I'd like to be running a lot faster than this, but I actually can't speed it up. I don't know whether it shows, there's a bit of offset in the block, weight wise, and if I go much faster than this, which I'm doing, what am I doing? Just over 500, lathe starts to jump around being such a small lathe. So, here we go again. Squeals a bit for about the first ½ millimetre because of the hardened material. That's into depth. I'll just gently come back out again. Okay. Getting down to the nitty gritty of it now. $17.89. I think I'll take, I don't know, 0.05 aside. We should be around about the 18 mil. Okay, same again. Let's have a measure. This could well be there now. Huh. 18 on the button. I think what I'll do, I'll just get my compound down and have a quick measure. Can't remember the exact size, whether the clearance is on the stub on the compound, which I'm about to show you when I can open the bag. Yeah, we want a clearance on this stub on my compound slide. It's not going on mine, it's not my tool post, but I'm just going to have a quick measure of that. I believe that's just under 18. 17.94. Okay. So it's 2,000 clearance if I leave it where it is. 18 on the button. I suppose the proof of the pudding is to take my compound and it should, and it does fit. Okay. I think the answer here is to leave it alone. I'm just going to put a little break edge on that outside edge, even though there is an undercut in the block. I can, where can I get to? Can I get there? We'll see in a moment if I can get in there. Will the tool rub? I haven't got that much trouble on my cross slide. Okay, not to worry. Let's see, can I do it with that one? Just a little break edge. No, it's fouling on the underneath. Okay, bound to find a tool to do that. What I shall do is my old trick, run the lathe backwards, put it on the far side. Let's just see if this tool post clears. Not like that, it don't. Okay. Let's have the boring bar sticking out a bit more. Not a fan of this, it might shatter a bit more. Let's get somewhere more like the angle we're looking for. Get the lathe running backwards. Again, this is going to be hard here. Right, nothing fouling. Just looking for that little break edge there. Talk about oil stones, I got an old Moore and Wright box here, and yeah, all sorts. Oh, bring them into shot aid. All sorts of oil stones. Yeah, multiples. So there's a little square one with a point on it. Where are we? Right, that will probably do me for what I'm looking for. So let's bring it forward, back into forward gear. Start her up. Oh, can't run it that fast. Much better. Just get on that one in the inside as well. Okay, I think we've done it. So there we are, 18mm diameter on the button, and it's about 6.4 deep, which is clearance on the 6mm step. So having fitted it on there, I can see a little issue. Where these turn, the major diameter gets quite close to the thread. I'm just going to put an M10 nut on there, which is basically what one could use, and it's just, you know, if the point of the nut is facing, they can just, you know, it will miss if it locks in the right orientation, but these, when the highest point of these comes towards the bolt in the middle, it could rub on the nut if we were to use a nut and washer. This is the sort of original Warco washer I had, and again, if you use these, you know, you're going to have problems. Or are you? Let me just see. So that would come there to unlock, but it won't come quite far enough back, and then when it's locked, they're out of the way. I mean, it would work. That's my handle and my washer, and again, as I come down, I'm hitting on the adjusting screw, so it's not the ideal situation. I'm wondering if, first of all, we were to make a brass washer that goes down on the top, of a small enough diameter, something a bit smaller than that, so that's good. We can clean that up and make a washer out of that. And then perhaps a piece of stainless with a thread up it, coming up so far to get us up above this height, perhaps with a hexagon milled on it for a spanner. I think we'd be probably in a better position. So I think, even though it's not part of my remit to make this nut, so the guy can get onto it, a guy called Marius, can get it straight on and use it straight away, and give him this tool post to be able to make whatever he likes for the top, really. He might want to make a handle like this, something like this, you know, so that it can be loosened by hand. We don't need the tool. I don't know, but at least we'll have something on there that he can use straight away. So 3-jaw back up. Face off that bit of stock. I think this is 3/4, so 19, so just going to set a 0. Maybe take a mil off it. Have a quick measure of what diameter that is. Looking for about 17.95. Cool. Pretty much hit that in one. 10mm spot drill. I've got these prepared ready. let's just get it. Let's follow her up with a 10mm drill. Should drill a few thou over size over the 10mm thread anyway. Go in about 6 or 7mm. Where's that? Let's have a look. Bring the flutes parallel to the edge there. 1, 2, 3, 4, 5, 6, 8, 9. Okay, that's 10 or 11mm deep there. Let's have that drill out the way. Get my Noga now out the drawer. A little chamfer in there. Let's get the tool out of the way. Little chamfer on the underside. Could do a little chamfer on the underside of what's going to be the part. So let's have a look. That'll do me. Is that the tool I wanted? Yeah, where's my chamfering tool gone? Anyway, that'll do. That will do the job. Only a break edge I'm looking for. There we go. And I think we need to part him off now. So, parting tool. Let's go and take a quick look, see how thick I want this washer. I'll set my parting tool. Okay, I'm going to stop there and swap back to that little B tool I had just now, if I can find it. There it is. Put a chamfer on the top face, or what will be the top face. I'll just drop that tool in there. Chamfer that top face. Back to the parting tool. Pick up that groove again. Not bad at all, found it. And we'll finish parting him off. Just catch him on an Allen key. And here we go. So that's the washer done. Let's have that tool out the way. Going to need to put a little chamfer in the top face of there. Let's have a look, see if we can do that in a 3-jaw. Might be able to just about do it. Come on, out of the way, carriage. Got a little burr on there, which I need to take off. So, Noga. Let's remove that. Okay, so we got our little washer, finished item. Yeah, next job is make the nut. I got a piece of 20mm bar stock. It's tough stuff. I don't know what it is. It's Foundium. Yeah. Right, so for the bottom 6mm, I want to come down to that same sort of diameter of 18. This is 20mm bar. Hold on, let me just do a touch off. there. Okay, 20mm bar with the touch off on the OD. What did I say, 18, so that's going to be 2mm off the diameter. So let's just take a few scratches. A couple of little champers on the bottom and an M10 thread. Set a 0 there. Let's get an idea of what diameter that is. 19.6. It'll go in a 19 to 20 collet, so that's good. Right, yeah, a couple of little champers. What have I done with that champering tool? Oh, I can see the tool, but it's not in the tool holder at the moment. Never mind. Jumper on there. Jumper on there. I think we'll get a bit of emery on there, make that look a bit more respectable. So tap and drill for M10. M10 is 1.5 pitch. Take the 1.5 from hang on, take the 1.5 from 10mm, and it gives you 8.5. So 8.5 drill. And I'm going in about, once it shuts up, going in about 20mm. Right, okay. So we'll go 20mm from there. Get a bit of lube on that drill. So just using a spanner on the jaw, we'll put this tap in, I don't know, 10 or 12 threads, or yeah, we'll get it past the taper. In fact, I think we're there. And I'll finish tapping it on the bench. Whoops. Okay. Will that tool go deep enough? Yes. And that is about to drop off. There you go. Right, I'm going to put it back up in the chuck, vice that end off and put a chamfer on it. So let's have that piece out of the chuck. Oh, those jaws are ick. Okay, put him back up that way. And I'll face that off. Cool. Put a chamfer on there. Oh, I must set that chamfer tool back up. ready to go to the mill. So set up in the hexagon block in the mill, enough sticking out, and we're going to put a hexagon on the end for a 17 spanner. I've just measured it, it's 19.6. So a little bit of maths, 19.6, 17 leaves me 2.6 to come off. That divided by 2, same up each side, is 1.3 mil. So I think I'm going to touch on one side just till I hear it scratch. I'm going to take 1.2 off. I'm going to rotate the block 180 degrees, do the same the other side, and just get myself a bit of a gauge measurement for a 17 mil spanner, and then I can just do the same cut on all of the 6 sides. So I establish the initial side, or 2 sides, make sure we're on the 17 mil, check the spanner on it, spanner fits, so same setting, I just keep rotating the block. Do a cut, back and forth, turn the block, do a cut, back and forth, and that's giving me the 17 mil hexagon on the end for a spanner. So that's that way, wait for it to spark out as it were. Other than tapping the hole, I think we're done. Maybe need to put a little bit bigger chamfer on the end of there. We'll get to that. Anyway, happy days, that's the hexagon. Well, there we are, that's it in place. And yeah, I mean, we've got something that now can be used and works. Yeah, I mean, you could put a dome on that, put a handle in and an angle. There's all sorts of things you can do, but at least it'll get him away so you can use the tool post. Happy days. Well, there we are, guys. I think that's quite enough for this episode. It's going to be 30 minutes or so. Still sporting the Christmas jumper. Can I take this opportunity? I probably won't put a video up beforehand, so to wish you all a very Merry Christmas. None of this Happy Holidays thing, I don't believe in all that. A Merry Christmas it is from Wales, and a very Happy New Year. Let's hope it's a better year than 2020 was. Anyway, that's me out. Cheers, guys.